welcome to Google Cloud in Singapore. My name is Qiu Rong. I'm a customer engineer working in Google Cloud. Thanks for joining me today for the first session to get to know about Google Cloud Platform. So before we get started, I would like to understand more about you. Please raise your hand if you develop on day-to-day basis. Great. Please raise your hand if your role is system work. How many of you do both? Wow, quite a couple. How many of you manage a team which develops or do system work? Wow, we have quite a number of managers here in this room. And since this is an introductory session, how many of you already have experience with Google Cloud Platform? All right, now I know how I should pace my session accordingly. Let's get started. So first of all, there are tons of GCP products. And we have compute, storage, big data, AI, management, networking, and open source tools. And there will be more and more products coming. In the keynote just now, last year alone, we have launched more than 100 products and new features. We won't be able to talk through all of them today, but since this is an infrastructure track, we'll be focusing on the most fundamental and probably most essential service, Google Compute Engine, the GCE, and also showcase some of the complementary technologies that we'll need to work with GCE. Lastly, to expand from your first project and introduce concepts and best practices on resources and cost management, since this is very, very important. Now let's get started. So the basics, just give me a VM. Google Cloud Compute Engine is our cloud virtual machines that have a wide range of options, from shared cores to 160 processors, up to 3.8 terabytes of RAM, which essentially, if you're running a server rack, is one full server rack. And for attached disks, we have up to 64 terabytes of disk, or locally attached SSD for up to 3 terabytes. Now I'm just going to demonstrate to you how fast it is to create a machine on Google Cloud Platform. Please switch to demo. So this is the Google Cloud console that I'm into my projects, and this is a list of VMs I have in this project. Now I'm just going to create an instance. And I have a name called Instance 1. For the region, I will pick Singapore, which is the nearest one. And the zones are fully randomized, so just pick whatever number you like. There are 3 types of machine configurations: general purpose, memory optimized, which is an ultra memory machine suitable for workloads like SAPs, or compute optimized, that is using the latest Intel Cascade CPUs suitable for high performance computing. For the demo purpose, I will just pick a general machine with N2 standard 2 type. When I scroll down, I can attach GPUs or choose a CPU platform. On the boot disk side, there is a wide range of OS images from CentOS, Debian, SUSE, Ubuntu, and also a full list of Windows OS supported by Google Cloud Platform. And you can also have application images running Windows SQL servers, as well as you can build your custom images. So for here, I will just put a Debian, and I choose a standard persistent disk of 10 GB. We're almost done. So here, I just choose default service account to access to GCP and allow HTTP traffic. And there's additional setup for you to set up your firewall, your key management, etc., or choose your machine to be preemptible, or choose a maintenance type. Before we hit create, here is a really good function that have the equivalent REST API or command lines for you, so that instead of trying to figure out where the G-Cloud commands are and trying to type by yourself, you could copy and paste and modify from the list of commands and just to script it. And now I'm just going to create a machine We like to say that we can spin up a machine in tens of seconds. It's usually because like when I practice at home, it takes about 10 seconds. And when I'm in front of public, it takes longer. And I'm not very sure, maybe the machine is also anxious in front of the public like I do. So now I'm just like waiting for the machine to get started. And here we go. Great. So we have this instance created in a few minutes. And it's here is this little SSH button, which I really liked. So you don't need to, if you don't want to set up your own terminal, but using SSH into the browser, that the browser will pull up the SSH keys for you. So it's quite easy to use. Here we go. And now we are getting into the machines. I'm just going to run some commands. For example, get update. And it's installing the updates, and now the machine is ready to run. So it's pretty simple and easy, isn't it? And now let's switch back to the presentation and talk through what we have seen just now. So there are 3 ways to interact with Google Cloud. Everything you did from the console, like we saw just now, you can do it from G-Cloud commands or from REST APIs. First, we just created a VM. Then we run commands, running stores onto that. After that, we start to copy files and put my codes over. These are basically the 3 major steps you will need to migrate your stuff over to GCE. Next, we talk about storage. We briefly shared about the disks. And for storage option, we have the block storage that is having 11 nines of durability and highly available globally, as well as the file storage, which is good to store hierarchical files. Here is a performance comparison of the disk options. As you could see, the local SSD has a superior performance in terms of IOPS and throughput. However, because the SSD is attached locally to a physical host, so the data will be lost when the machine is shut down. You are recommended to use other instance options together. For example, persistent standard disk or SSD disks. Both of them can be stored in a zone or replicated in 2 zones in the same region. Next, VM images. Just now, we showed a long list of pre-built images that's supported by GCP. We have multiple flavors of Linux and as well as multiple flavors of Windows machines. IP addresses. From the list we just showed now, each instance is created with one static and one public and private address. Both of them will be ephemeral, which is the default options, and they can be converted into static address. Just one note here that starting from next year, the IP addresses is going to cost you if you convert an ephemeral IP address into static, but not using it. So the incentive here is clearly to discourage you from holding on to a bunch of IP addresses without using it. Firewall rules. It's pretty simple and easy to create firewall rules as well. You create the rule, open up the ports, allowing the traffic, give the rules a tag, and tag the machine to the rules that will open them up. Now, we have talked about the basics, and that's probably the minimum for you to create a VM. Let's talk about something not so basics, and probably that's also something differentiate GCP from others. You can custom build your images from source disk images or snapshots. You can start with a list of our machines and get it stored and save it as a static image. And whenever you need to create a fleet of machines, for example, auto scale up, you can build and boot from here. And for images that are not supported by GCP, you could bring your own images using tools like VirtualBox. We talk about the VMs, and for graphic workloads or machine learning workloads, we also support a wide options of GPUs. In Singapore region, we support the NVIDIA P-Force and the T-Force, which is the latest NVIDIA GPU type. And for we also purposely built the machine learning purposely built the chips that is called tensor processing units that is optimized for machine learning workloads. From a ResNet 50 performance benchmark that the cloud TPU V2 pods performs 27 times faster in training and 38% lower cost compared with 8 pieces of V100s. Both GPUs and TPUs have preemptible pricing options, which gives straight 80% off. We're going to talk about that later. And both of them cannot be live migrated. So what does live migration do? From the keynote, you probably heard from one of our speakers that one differentiator for running SAP workloads is the live migration technology. It is by default for GCEs, and so for machines, there is oftentimes hardware or firmware updates. And during the updates, instead of shutting down your VMs, Google Cloud will live migrate the instance to another physical host in the same region, so that without disruption to the production. And here's a story. Back to some time ago that there was a major zero-day vulnerability happen to one of the chip manufacturers. And actually, essentially, everybody who runs a server need to run update. However, only Google Cloud's customers didn't notice the disruption because everything was done through the live migration in the backend. We're just going to take a short detour here to talk about Cloud Shell. Just now we demonstrated SSH button, and Cloud Shell is another browser-based virtual machine that is loaded with all the development tools that you need. For example, gcloud, Git, Kubernetes, and so on. The best part is that it is for free, so you don't need to, or if you don't want to set up your own terminal, but use Cloud Shell in the browser to manage your resources and projects for GCP. Next things, after you create your VMs, you probably want to run your operation a bit bigger or more managed. So here it comes to the instance groups, managed or unmanaged. For managed instance groups, you create a VM image template that which we just outlined earlier, and create images in this group using the template. Because the instance group using the exactly same template, you can auto-scale or auto-heal. You can set machine utilization of 60%, for example, and when it's above 60%, you start a new instance using a template. And when it goes below 60%, a machine will drop off. You can also set the lower or the upper limits of the size of the instances. Next thing with instance groups will be you need to hook it up with a load balancer. And here again, we have a wide range of load balancers here supporting multiple traffic types. We have internal load balancers that load balance internal traffic without exposing it to the public internet. We have external load balancers that is taking in the traffic from the internet. We have regional and global load balancers, and use the global load balancer when you are using it to distribute traffic across multiple regions. And customers love it when your entire app for the global is available via one single global IP address. And it's all under Google's premium network tier. So why we can do this? We're going to come to this map again, which probably also see from the keynote and is going to see from other sessions, from the breakout sessions, is that something we are really proud of our infrastructure and network is we operate our own private network connecting our regions across the globe. So you can see the dots, that's our regions, and the lines are the private network, or we also invested in the submarine cables. So in standard internet, we practice hot potato routing. So as the name tells, you just pass the packets as fast as possible. And with Google Cloud, we operate cold potato routing. So which means we'll try to hold the packets as long as possible within our private network. What does it mean to you? It means that you could have high, consistent throughput and low latency, as well as you are going through fewer networks that become more secure. So this is what we meant by premium network, and this is by default without additional cost. So it's here, I'm just going to run a very quick demo app to show how data is transmitted across the world. Okay, let's switch back to the demo. So I have this demo app that I'm going to pull an image, which I took from the keynote earlier on today. That app is going to travel across the world and with a stamp on each region. So you could see I go from Taiwan to Tokyo to Sydney to US West to US East and all the way to Europe and South America. And it takes in total less than 4 seconds to go around the world through our private network. Essentially, we just open a VM in every single region across the globe, and under this private network, the VMs got to talk to each other directly without going through the public internet. So that's why it's so fast that it takes just like 4 seconds. Can we switch back to the presentation, please? We're just going to talk a little bit of our networking products, that the virtual private cloud is a global service that allows the VMs in the same project, in the same virtual private cloud, could communicate directly with each other without going through the public internet. And when we are trying to connect from your on-premise infrastructure to the cloud, we have Google Cloud Interconnect that creates a dedicated connection from your on-premise infrastructure to peer to one of GCP's edge locations. And Cloud VPN securely connects your on-premise network to GCP. So you have created a VM, have your code, set up your network, and your project is ready to go production. Soon your manager, since we do have a lot of managers in the room, will be asking you about budget optimizations, and you'll probably have more team members joining you for the same or different projects. So for the later part of the presentation, we would like to talk about access and resource management, because from one single Hello World project, we find it so much easier to set it right before you are getting more complicated and more projects running. One of the best things you can do is to start off your resource hierarchy correctly. So here is an example of resource hierarchy that you can use this hierarchy to easily map to your own organization and to GCP for the purpose of organizing your services to be easy separation, delegation, and inheritance of policies. There are 3 key types of objects in the resource hierarchy: the organization, the folders, and the project. On the right, there's a $sign, which is the billing account that is attached with the project or the organization we're going to talk about in the last part. So first, the organization. This is the very top of the resource hierarchy and is automatically provisioned when you sign up for Google Cloud, with an organization node, which usually represented by the company's domain. The projects belong to the organization instead of the employees who created the projects. Employees can create, sync, manage users within the organization using Cloud Identity, the Identity as a Service platform. Google Cloud Identity integrates your cloud and on-premise directories in one and is independent of G Suite or GCP. So we have a free version, which is great because before that, many customers use personal Gmail account to sign up for GCP, and that's definitely not ideal for organizations. And we also have a paid version, which with a lot of enhanced security and device management features. Next are the folders. Folders can be used to split up your GCP services in a manner that match your own internal structure, be it by departments, by projects, or by environment. With folders, you can give teams and departments agility to delegate the administrative rights while also enable them to run independently. You are allowed to have up to 4 levels deep of projects and folders. Finally, we have the projects. Ultimately, your workload and GCP all reside in one project, which provides an isolation boundary between resources. A common practice is to separate your dev and production environment into 2 projects, and which also makes project the frequent attachment point for policies. So we talk about the resource hierarchy. Now let's come to the cloud identity and access management. So IAM itself is essentially about who can do what on which resources. Let's talk about the who. Who is the users and the groups and the service accounts. And now we talk about the what. So the what is all about the roles. The role is a set of permissions that is expressed in the service.resource.verb format. So the permissions aren't granted individually, but instead we use a group of permissions that is given to a specific roles. We have a set of predefined roles, but if you need a more granular control, you can also use custom roles to set a preset set of permissions. Let's talk about the on what. In GCP, you can apply policies to resources themselves. The typical attachment point will be the organization, the folders, and the projects. Depending on where you attach the policies, the role, in fact, the permissions will be different. The access you granted in a policy inherits down to everything below that level. Let's take an example here. If you give a user a storage bucket admin to an organization node, that gives you the user access to every bucket in a GCP organization. Similarly, if you instead give it to them on the first folder, it will give them access to all buckets in the 2 projects underneath that folder. And finally, applying the policy to specific projects will only grant the users access to the 3 buckets in that project. When we put everything together and use this as an example, here are some of the best practices. First, group your folders and projects based on access commonalities, be it by BUs, by teams, applications, environment, and so on. And we talk about the inheritance downwards. At the same time, the child policies cannot restrict access granted at the parent. For example, if you grant the editor role to a user for a project and grant a viewer role to a child policy, a child resource, the child resource will still have the editor role. So within the IAM, always follow the principles of less privileges. Lastly, assign permissions to groups rather than individuals. You certainly don't want the owner, the single owner, leave the company or he lost his account for any other reasons. With all this, the benefit of arranging things in this manner is that we could significantly reduce the number of policies that we need to manage, at the same time maintaining the desired amount of isolation between the business units. So let's talk about the favorite part, pricing. So we decided to put one part for this is mostly because for most GCP projects, VMs is one of the biggest portion of the cost. And also understanding the cost correctly in the cloud will essentially make or break a migration project. Let's talk about how we can understand our cost better. We talk about projects own resources, and here every project is attached to a billing account that pays for the project. The permissions for the billing accounts and project will be different. You can have an organization-wide billing administrator who have full access to everything about cost, but have no access about the GCP resources. So every billing account will receive a monthly invoice, looks like this. And from the front page, it summarizes information about your account, your company, and also the total amount due, followed by a few pages of breakdown of cost by SKUs. But you don't need to wait until the end of the month to understand your cost. You can always go to Cloud Console to check out the billing reports to gain visibility of your up-to-date spending, analyze the trends, and also to forecast your end-of-month spending. You can also filter your costs by time frame, projects, products, or the customized labels that to give you more fine-grained view about how you're spending. So your invoice always tell you how much you own, but always go to the billing reports to understand why and where your costs come from so that you can better optimize from that. So in the later part, I'm going to talk about the pricing controls and also usage controls that you could use to help optimize your usage and cost. First of all, is a sustained usage discount. It's an automatic discount that you don't need to do anything. Essentially, the longer you use it, the larger the discount you will have. You will have up to 30% off for the VM instances that you use. The best part is that the discount is not counted on one single instance, but again, combine the usage to the whole month and try to maximize the discount for you. So you don't need to do the mathematics and trying to arrange your resources. You just go and use it, and we'll do the rest for you. I'm going to have a quick illustration of how sustained usage discount works. So here is my monthly usage. I have an instance running for half a month, and I have a second instance running for another half a month. And then I add on to the capacity and instance for a very short period of time, the instance 5. So none of these instances have been used for the entire month. And with inferred instances, we combine the unoverlapped portion throughout the month and to try to make sure this going to utilize for a full month. So the total discount will look like something like this. Instance 1 and 3 add up to one whole month, and they will be having additional 30% off. And instance 2, 4, and part of 5, they are using probably about 80% of the month, which will give them roughly 20% of discount. And instance 5 is less than 50%, so there's no discount. So basically, you can save more than what you have thought you have done, and also maintain the flexibilities of the on-demand nature of cloud. So that's great, right? So for people who are not really running instances for a month, but running now for a year, we have more discounts for you, which is called committed usage discounts. You could have up to 57% off by committing your usage to 1 to 3 years. Locking yourself to 3 years to the same hardware seems not very cloudy. So our committed usage discounts will allow you to change and reconfigure the RAM and the processors that you have, as long as you keep the total number of the commitment the same. So we talk about the pricing controls, and now we talk to the usage controls. First, we have the custom VMs that I believe oftentimes you want to have more cores or more memories, and instead of upsizing it, it's going to be underutilized. So with custom VMs, you can just configure whatever you want. And from the very first demo we did very earlier on, you probably see there's a light bulb saying, oh, please, this machine is underutilized. Please change the size that you could save $39 more over a month. So essentially, throughout your operations, our intelligence will closely monitor your utilization and give the recommendations for you. So on average, custom VMs could help you save another 15% off. Lastly, we have the preemptible VMs. So cloud, we all run over capacities. With this additional capacity, we are willing to rent it out to customers at a lower price for a shorter period of time. So preemptible VMs essentially give you 1/5 of the cost, while it will be disappear sometime within 24 hours. It is ideal for users who are running burst state workloads, for example, machine learning trainings that you're just going to run a few hours over the day, and you are going to save significant amount from here. Wrap it up with the pricing controls. You could maintain the flexibility of your GCE instances while just keep using it. You go up to 30% discount, and you could also optimize with the usage of custom VMs, preemptible VMs, and committed usage. Now come to the conclusion. So for this session, we talked a lot about Google Compute Engine. And the reason why is that Compute Engine is a fundamental service that many products actually is built on top of a VMs. And you could apply the similar strategies that we talked about earlier to these products. For example, you could use preemptible VMs to run your data proc Hadoop workloads and so on. And if you are willing to learn more about GCP's database and storages, GKE, security, or AI features, here are some of the breakout sessions I would recommend you to go and to know more about that field. Lastly, do check out our dev zone if you want to try out the hands-on. We have the quick labs over there and also other few games and prizes for you to win that you could do. You could try out GCP on a sandbox environment without opening a project and so on. So that's all for me today. Thank you, and please enjoy the rest of Cloud Summit.